Hello, welcome back to Chapter 7, Section 4, where we're talking about the properties of logarithms. So we did the product property, the quotient property, and the power property in the last three videos. There is another set of properties. They're both called inverse properties because inverses of each other. It's just both of them like go different directions, I suppose. Okay? This all comes from the idea that the logarithm is the exponent. It comes from our definition of logarithm that we've explored in Chapter 7, Section 1. So it seems pretty straightforward, but to be honest, it allows us to solve problems that involve huge exponents. Okay, so if you get a chance, look at the example, I believe it's example 6 in this book with the Richter scale problem. So that's actually kind of useful. But then there's other examples we'll be doing too for the application problems. Inverses show up in solving equations. Like for example, if I have a real simple equation, x plus 4 equals 12. The number 4 has an additive inverse, which is negative 4. Those are called opposites, but their real name are called additive inverses. 4 plus negative 4 equals 0. And when I add 0, nothing changes. So when I solve an equation like that, I'm going to add the additive inverse to both sides. Reciprocals are called multiplicative inverses. Same thing. So if I'm going to say 3 times x equals 15, I'm going to multiply both sides by 1/3, which is the same as dividing by 3. So we need to have inverse properties involving exponential functions and logarithmic functions, which switch the two of them so that if I needed to solve an equation, I could. Like for example, if I have log base b of something, b to a power, then this is literally asking b to what power equals b to the x power. I'm going to say that again. B to what power equals b to the x power? Well, since the bases are the same, then the exponents have to be the same. And it'd be like, wouldn't it just be x? So 7 to what power equals 7 to the 4th power? Well, duh, 4. So that's what you're doing with this property. All right? The other one's a little bit more complicated to see, but if I have a if I have a base and the exponent, remember the logarithm is the exponent. If the exponent is written as a logarithm with the same base, then whatever goes inside my logarithm, the input of my logarithm, is what I get. So these are two ways that we can talk about inverses. So for example, if I had, I'm making this up on the fly. So let's say I have something where I have log base 5 of x equals, I'll say 32. So I would want to solve for x. Okay, so the logarithm is the exponent. I would write it now like this. 5 to this power, log base 5 of x, equals 5 to the 32nd power. Now on the right side, I'm going to get a huge number. I guess 32 would have been too big, okay? Here, I'll even show you. 5 to the 32nd power. It's got like 23 places, okay? So that would have been too big. But here's the important part. Over here on this side, I get x. So x is going to be whatever 5 to the 32nd power is going to be. This allows me to solve for x, to isolate the x. And that's why we use these properties. So we're going to practice it with a couple of these. These are, like I said, this really isn't anything important by itself, but it's very, very, very useful when I come across equations that I need to solve with logarithms. All right, so This is log base 8 of 8 to that power. Remember, the logarithm is the exponent. This is just whatever 3x plus 1 is. And you're probably thinking, is that it? Yeah, that's it. This one I got to do a little bit of work. This is log base 5. 125 I know is 5 to the third power. So again, the logarithm is the exponent. This just equals 3. And for the last one, I have 2 raised to a power that has a logarithm. So since that base of the exponent is the same as the base of the logarithm, this just equals 27. That's all. So this would be 2 to what power? This right here would be the exponent. 2 to what power equals 27. I know 2 to the fourth power is 16 and 2 to the fifth power is 32. So it's going to be 4 point something. Log base 2 of 27 is that exponent right there. Okay, I know there's not a lot of examples in this first video. It's a little short, but we'll be doing more examples when we get to the guided practice problems.